condition with special reference to its Volt-Ampere characteristics, breakdown voltage, new voltage and its operational limitations. As we all know, a PN junction is formed by joining a P-type and an N-type semiconductor. It is a very important electronic device because it allows electric current to flow only in one direction. First one is its their characteristics. The VI characteristics of a PN junction represents the relationship between voltage applied across the diode and current flowing through the diode. These characteristics are studied under three conditions. First one is zero bias. These are the three conditions. In zero bias condition, when no external voltage is applied, the depletion layer remains inactive. Which means that when no external voltage is applied, the PN junction region near the PN junction does not change. That region is called the depletion layer. It contains no free electrons or holes, so it acts like an empty zone. Empty zone between the P-type and N-type material. Next is the potential barrier prevents the flow of charge carriers. The potential barrier acts as a wall that stops electron from the N side and holes from the P side from crossing the junction. Hence, no current flows through the diode. So the current is zero under the zero bias condition. Next is the forward bias condition. In forward bias condition, the P-type semiconductor is connected to the positive terminal and the N-type semiconductor is connected to the negative terminal. Once the barrier is overcome, the current increases rapidly with a small increase in its voltage. Next, we need to know what is an E voltage. E voltage means it is the minimum forward voltage at which the current through the diode starts increasing rapidly. For a silicon diode, the E voltage is 0.7 volt. For the germanium diode, the E voltage is 0.3 volt. Below V voltage, the current is decreasing. condition, the p-type is connected to the negative terminal and the n-type is connected to the positive terminal. This is the breakdown voltage. When the reverse voltage is increased beyond a certain limit, the diode suddenly conducts a large reverse current. This critical voltage is called breakdown voltage. At breakdown, the reverse current increases. The resistance increases suddenly. And the diode may get permanently damaged due to the excessive heating. Therefore, the reverse voltage must also always be kept below the breakdown voltage. Next is the operational limitations of PN junction diode. First one is the maximum forward current. It is the maximum current the diode can carry in the forward bias. If exceeded, the diode may overheat and get damaged. Second one is the peak inverse voltage. It is the maximum voltage that can be applied to the diode without causing any breakdown. Exceeding the peak inverse voltage may destroy the diode. Next is maximum power rating. This is the maximum power that can be dissipated by the diode without damage. These are the three operational limitations of the PN junction diode. This graph shows the VI characteristics of a PN junction. That is how the current changes with the applied voltage in both forward and reverse bias. At the point O, the external voltage is 0, so the current is also 0. This shows that the diode does not conduct without biasing. Initially, when the forward voltage is applied, the current does not change. This is because the diode has a barrier voltage. At point A, this is called, here is the E voltage. After this voltage, the potential barrier is almost removed. When the diode is reverse biased, only a very small current can flow through it. This current is due to the minority charge carrier.